Hey guys, welcome back. I hope you guys are having a good time. I hope you guys are happy, and we're gonna hit up this Pascal's triangle here. Happy New Year in advance, and I hope to see you guys soon. All right, let's get right into it. So, what is this Pascal's triangle, and how do we use it? So, start with a triangle where your vertices are all ones, right? So you're gonna write 1, 1, 1. And then what you're going to do, you're going to continue this. You're going to continue these ones as this diagonal here in that shape of a triangle. You're going to go 1, and then you're going to add up these two ones here, and you're going to put that number right there. So 1 plus 1 is 2, and then I'm going to continue with 1. And then you're going to just continue that pattern. So I'm going to go 1, and then 1 plus 2 is 3. So 3, and then 2 plus 1 is 3 again. 3, and then 1. And then you just continue forever and ever. 1, and then 3 plus 1 is 4, and then 3 plus 3 is 6, and then 3 plus 1 is 4, and then 1. All right, y'all. So I'm seeing this Pascal triangle. How do I use it? So it's pretty much used whenever you have a binomial and you're expanding it. And there is something called the binomial theorem or binomial expansion theorem. It just depends. Everyone calls it different things. Okay, it's not called different things. Depending where you look, some just call it binomial theorem. Some textbooks call it binomial expansion theorem. It's the same deal. That's what I'm trying to say. So let's take this one for instance, because we're about to do a third power in a little bit, anyways. So if I had a plus b to the third power, I would take that 3, and I would remember that 3 means that you're going to have 4 terms, right? So that means I go to the 4th row, or you can think of it as going to the first time that you see that 3, because there is an obvious pattern here if you go through that specific diagonal. So you go to this 4th row here, and it's supposed to look like this. So you're going to count down for your first exponent, the a, and you're going to count up for the b. So that 1 is your coefficient, so you're going to go 1a to the 3rd power, b to the 0. Plus, and then you're going to count down for the a, but count up for the b. Remember, your degrees cannot add up to more than 3. It has to equal to 3, always, all the time. So the next term, I'm going to write 3a squared b to the 1, plus, and then that 3 was that 3. Now I'm going to go to the next one, 3ab squared. I guess you can put the 1 there so you can see that it adds up to that 3 there, plus 1, a to the 0, b to the 3rd. And notice that they always add up to 3. 3 plus 0, 2 plus 1, 1 plus 2, 0 plus 3. Let me see if I can just delete that little line that we added. There we go. And of course, you don't have to show that. And remember, anything raised to the 0 power is 1. So you can just write a cubed plus 3a squared b plus 3ab squared plus, and then a to the 0 power, that's a 1, so that plus b cubed. And there it is. That's how you use it, guys. All right, so here we go. So I'm going to start off with x plus 4 raised to the 3rd power, guys. We're going to do it the way you guys have probably always done it, and then we'll do it with Pascal's triangle. Maybe you guys already know Pascal's triangle, and, go for it. But I just want you guys to see that it works. So, all right, guys. So on this one here, you see that 3rd power. So that 3rd power means that you have 3 of them, right? X plus 4 times x plus 4 times x plus 4. And and I think it's fairly simple to multiply two of these really quick. X times x, that's going to be x squared, plus x times 4, that's going to be plus 4x, and then 4 times x is going to be another plus 4x, and then 4 times 4, that's going to be plus 16. And then you still have that x plus 4 on the side. So let's go ahead and combine like terms first, these two 4s, or these two 4x's. So you have x squared plus 8x plus 16 times x plus 4. All right. Now let's see. X squared times x, that's going to be x cubed. All I'm doing is this. And then I'm going to go x squared times 4, that's going to be plus 4x squared. And not sure why my plus symbols are looking like little t's there. Plus 4x squared. I think we're good with that one. We jump to the next one. 8x times x, that's going to be plus 8x squared. 8x times 4, 8, 16, 32, so plus 32x. Then I go to the next one. 16 times x is going to be plus 16x. Then 16 times 4, plus 16, 32, 64. Adding everything up, you have x cubed plus 4x squared and 8x squared, that's going to be a 12x squared, plus, and then 32 and 16, 32, 42, 48, x plus 64. All right. There it is. That's with algebra, right? So now let's do it with Pascal's triangle. That says 3. So I'm going to go 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. I'm going to stop there. And I know that if I have something like a plus b raised to the third power, that it would be 1 a cubed b0 plus 3 a squared b1 plus 3 ab squared plus 1 a0 b third. So again, that means a to the third plus 3a squared b plus 3ab squared plus b cubed. All right, then we got to say what a and b is. So I come up here and I know that a has to equal x and b has to equal 4. So here we go, guys. I'm going to write x plus 4 raised to the third power equals x cubed plus 3x squared times 4 plus 3x times 4 squared plus 4 raised to the third power. So let's see, x cubed plus 3 times 4 is 12, so 12x squared plus 4 squared is 16. 16 times 3 is 48. 48x plus 4 times 4 is 16. 16 times 4 is 64. Did we get the same? Yeah, we did. And that's how you do it, guys. Yay! All right, that was fun. Let's see if we can do some more. All right, now that we have warmed up, so we're going to do Pascal's triangle again because it's supposed to be faster, right? So that 4, so I'm going to go 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. There it is. We stop. Stop. You're going to have 5 terms. 1, 2, 3, 4, 5. There it is. These are the coefficients, right? So first I'm going to say, how do you expand it? A plus b raised to the 4th power is going to be 1 a to the 4th, b to the 0, plus 4a cubed, b to the 1, plus 6a squared, b squared, plus 4ab to the 3rd, plus 1 a to the 0, b to the 4th. Now remember, your degrees have to add up to 4 at all times. 4 plus 0, 3 plus 1, 2 plus 2, 1 plus 3, and 0 plus 4. Yep, they always add up. They add up to 4 at all times. All right, I guess let me just finish it off here. B to the 0 is 1, so this is going to be a to the 4th plus 4a cubed b plus 6a squared b squared plus 4ab cubed plus b to the 4th. All right, I think we're good, guys. So I'm going to come back and I'm going to say 3 minus 2x squared raised to the 4th, where a is 3 and b is negative 2x squared. So make sure to put the negative, guys, because your expansion has a plus there, see? So that b is a negative 2x squared. So here we go. So I'm going to write equals, and I'm just going to follow this a to the 4th stuff. So a is 3, so 3 to the 4th plus 4 times a is 3, so 3 to the 3rd times negative 2x squared. So hopefully we're still okay. Plus 6 parenthesis a squared, so 3 squared times negative 2x squared squared plus, and we're here, 4 times 3 times negative 2x squared raised to the power 3 plus, and now we're in the last one, negative 2x squared raised to the power 4. All right, let's see what this is. 3 to the 4th. 3 times 3 is 9. 9 times 9 is 81. Plus, okay, be careful here, guys. You see that negative there? So maybe put a parenthesis. It's going to be negative, the whole expression. Well, I guess we'll do 2 more lines, right? 3 squared is 9. 9 times 4 is 36. And 36 times 2. Okay, let me make sure. Oh, okay, I almost made a mistake. I said 3 squared. 3 to the 3rd. 3 times 3 is 9. 9 times 3 is 27. 27 times 4 is 108. And double 108 is 216. So negative 216x squared. Child, what'd you do? I did the 3 to the third first. Let me go ahead and circle it and put 27 on it. This right here, that's 27. And then 27 times 4 was 108. And then I did 108 times 2, or negative 2. That's going to give you that 216, the negative 216. All right, continuing. Plus 3 squared is 9. 9 times 6 is 54. And double 54 is 108. But okay, hold on. It's not, you're not multiplying by 2 this time. So I guess what I should do is, you see this guy right here? Make sure you square it. So when you square it, that's going to be 4x to the 4th. All right, there we go. So now let's do it. 3 squared is 9. 9 times 6 is 54. And 54 times 4 is 216. And this time it is positive. 216. Oh, let me go back to blue. 216, and then the x to the 4th. Yeah, so you just got to be very careful, guys. Let's see. Plus, and then this is going to be a negative because it's raised to the third power. So let's do that first. So this guy right here, that's going to be 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. So it's going to be a negative 8 x to the 6. All right. So 4 times 3 is 12. And 12 times 8 is 96. You're going to be negative. So negative 96 x to the 6. And then plus, this is going to be definitely a positive. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So 16 x to the 8. I don't see any issues. I think we are good. So my final answer, so let me go ahead and write it right here. So my final answer, 3 minus 2x squared raised to the 4th equals 81 minus 216x squared plus 216x to the 4th minus 96x to the 6th plus 16x to the 8th. All right, I think we're good, guys. I think we got it. Let me make sure. Let's see, 16x to the 8th minus 96x plus 216x to the 4th minus 216x squared plus 81. Yep, we're good. Yay, we did it. All right, let's continue. Okay, so let's see. So we have this guy here. And again, to the 5th power. So I'm going to do Pascal's triangle. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. Stop right here. You're going to have 6 terms. 1, 2, 3, 4, 5, 6. Yep. And I guess let's just start with the expansion. A plus b raised to the power 5 equals 1, a to the 5th, b to the 0. Once you become a pro, you can just drop the b to the 0, but I would just keep it. Plus 5, a to the 4th, b to the 1, plus 10, a cubed b squared, plus another 10, a squared b cubed, plus 5, a b to the 4th, plus 1, a to the 0, b to the 5th. Make sure that your exponents always add up to 5. 5 plus 0 is 5, 4 plus 1 is 5, 3 plus 2 is 5, 2 plus 3 is 5, 1, there's a 1 here. 1 plus 4 is 5, 0 plus 5 is 5. Okay, we're good. All right, so let's see. I guess let's rewrite it one more time. Nice and pretty, right? A plus b to the 5th equals, the b to the 0 goes away, a to the 5th plus 5a to the 4th b plus 10a cubed b squared plus 10a squared b cubed plus 5a b to the 4th plus, and then a to the 0 goes away because a to the 0 is 1, plus b to the 5th. All right. Here we go. I'm going to go to blue. And I'm going to say, let's see, I'm going to write 3y plus 2z squared raised to the 5th. Chad, what are you doing, Chad? Sorry, my cat's here. A is equal to 3y. B is equal to 2z. Buddy, what's up? Nope, not yet, buddy. In a little bit. In a little bit we'll play, okay? 2z squared. Sorry about that, guys. So let's see. A, okay, here we go. It says a to the 5th, so I'm going to write 3y raised to the power 5 plus 5 times 3y raised to the power 4 times b, which is 2z squared, plus 10 parenthesis 3y raised to the power 3 times 2z squared raised to the power 2. I'm just making sure that I'm doing everything correct. Plus 10, another 10, right? Because now we're in this one here. 10 times 3y squared times 2z squared to the power 3 plus, and I'm going to head over right here, 5 times 3y to the power 1 times 2z squared to the power 4 plus, and then the last one here, it's just going to be 2z, nope, getting down. Sorry, my cat got on some papers. Plus 2z squared raised to the power 5. All right, I think we did it. Let's see. Let's see if we can do this. So I'm going to go right here. I'm going to say equals, and I'm going to say 3 to the power 5. 3 times 3. 3 times 3. Oh, man, I'm just going to need to take a calculator. So let me just take a calculator. In my calculator. That's an awesome picture. Here's my calculator. 3 to the power 5. 243. Yeah, we would have gone there eventually, but it's probably easier just to. 243 y to the 5th power plus, all right, so let's see. I'm doing 3 to the power 4 times 5 times 2. So 3 to the power 4 times 5 times 2. 810. 810 y to the 4th z squared plus, all right, 3 to the power 3rd, 2 to the power 2 times 10. 3 to the power 3rd times 2 to the power 2. And I guess we know that's just 4, right? But I think it's easier. Times 10. 1080. 1080. And then let's see. Y to the 3rd. Z to the 4th. Plus, all right, let's see. 3 squared is 9. 2 to the 3rd is 8. 9 times 8 is 72. 72 times 10 is 720. So let me make sure. Well, I'm sure we're fine. We'll check it in a little bit. Z to the 2 times 3 is 6. So Z to the 6. Let's see. 3 squared is 9. 2 to the 3rd, 2 times 2, 4. 4 times 2, 8. 9 times 8, 72. 72 times 10. Yeah, we're good right now. Plus, all right, 2 to the 4th. 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. 16 times 3, 48. And then times 5, 240. So plus 240 y z to the 8th. Plus, and then 2 to the 5th. So 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. 16 times 2, 32. So 32 z to the 10th. So I think we got it, guys. So 3y plus 2z squared raised to the 5th equals 243 y to the 5th plus 810 y to the 4th z squared plus 1080 y cubed z to the 4th plus 720 y squared z6 plus 240 y z to the 8th plus 32 z to the 10th. Okay, so hopefully in a little bit when we do delta, hopefully we don't get one of these super long ones. But there it is. I'm going to pause the video real quick just so I can log into delta, and I'll come back in a little bit, guys. All right, guys, so here's the question that I got. It says, use Pascal's triangle to expand 2z minus y squared raised to the 3rd. Express your answer in simplest form. That just means... Yeah, simplest form just means you don't want to have a square root in the bottom, all that good stuff. But they're making it easy for us, so you'll be fine. So 2z minus y squared raised to the third. So I'm going to come back and I'm going to write it in here. 2z minus y squared raised to the third. And here we go. So we got 2z minus y. Short-term memory, guys. Was it y squared? Yeah, y squared. 2z minus y squared raised to the third. Okay, so here it is. 1, 1, 1. I'm using Pascal's triangle. 1, 2, 1, 1, 3, 3, 1. We're going to stop there. There's going to be 4 terms. Stop. And here we go. So I'm going to say if a plus b raised to the third, it would have been 1a cubed b to the 0 plus 3a squared b to the 1 plus 3ab squared plus 1 a to the 0 b cubed. And make sure that everything adds up to 3. The exponents, 3 plus 0, 2 plus 1, 1 plus 2, 0 plus 3. Yep. So this would have been a cubed plus 3a squared b plus 3ab squared plus b cubed. All right, perfect. We're going to state what is a and what is b. So since I have 2z minus y squared raised to the third, a has to be 2z, and b has to be a negative y squared, because your binomial expansion theorem, your binomial expansion to the third power is a plus b, guys. So you got to keep that negative. All right. So now we're going to say, all right, so now we're going to go equals, and it says a cubed, so I'm going to write 2z to the third power plus 3 parenthesis a squared. So I'm going to write 2z squared. Look, 2z squared on the outside, guys, times your b, negative y squared, plus 3 times a, so 2z times your b squared, so negative y squared squared, plus b cubed, so negative y squared to the third power. All right, we're good. And let's see what this is. So let's say 2z to the third power. 2 times 2 is 4. 4 times 2 is 8. So 8z to the third. So that's what they mean by simplest form, guys. Do not leave it like this. You got to simplify that. Plus 2 squared is 4. So 4 times 3 is 12. But don't forget that negative. So negative 12 minus 12 z to the 4, z squared, y squared. Let me make sure everything's correct. 2 times 2 times 2 is 4. 4 times 3 is 12. Z squared, y squared. Yep. This one I'm squaring it, so it's going to be a plus. Let's see. 3 times 2 is 6, so 6z. And then y squared squared is y to the 4th. I don't see any issues yet. Minus 2 to the 3rd. That's going to be y to the 6th. I think we're good, guys. Let's see. I don't see any issues. Yeah, I think we're good. So 8z cubed minus 12z squared y squared plus 6z y to the 4th minus y to the 6th. All right, let's type that in. Eight z cubed. Where are you? 8z cubed. I already forgot it, guys. Minus 12z squared y squared. So let's see. Minus 12z squared y squared plus 6z y to the 4th. 6z y to the 4th minus, and I want to say it was y to the 6th. Yeah. Minus y to the 6th. All right. If there's no issues, hopefully there's not. Yeah. And there it is, guys. I love, they do really good job they do a good job of this. I agree with how they're setting that up. All right, guys. See if you guys can tackle it. See you guys later.